Hello everyone. Today we are going to be finding equations from vertex and factored form. So we'll be looking at graphs and trying to figure out what their equations are, which is the opposite of what we just accomplished. We had equations and we graphed them from the equations. The big thing you want to look for here in a graph is, do you know the vertex or do you know the x-intercepts? Okay, sometimes it's not very clear. Your x-intercepts might be decimals. They might look like 1.5, but really they're 1.6. But on the same graph, you absolutely know the vertex, and therefore you would want to find the equation in vertex form. And it could be vice versa. The vertex is a decimal, but you know the x-intercepts, so you would want to write the equation in factored form. Okay, for these first two that we look at, A and B, you can see that the x-intercepts go through, again, like I said, at decimals. But we clearly know the vertex. Okay, and we know that vertex form is y equals a bracket x minus h squared plus k. All right, so what do we know? We know the vertex is at 4, -5. And the other thing we need to know is a point. We need an x and y in order to solve for our a. So we can take this point right here, which is at 2, 3. Okay, now we have an h, we have a k, an x, and a y. So we can plug all those into our equation to find the a value and finish off the equation for this graph. So our y value is 3, don't know a, x is 2, h is 4, and k is -5. All right, so again, don't know a. 2 minus 4 is -2, and -2 squared is 4. Okay, so we have 3 equals 4a, because a times 4 is 4a, minus 5. So we're going to want to add the 5 to both sides to get rid of it. 3 plus 5 is 8. 8 equals 4a, so we divide by your coefficient, and a equals 2. So therefore, the equation is y equals a value of 2, h value of 4, k value of -5. And there's the equation. We could have also on this graph, if it's clear, figured out the first time, or sorry, how many you count up if you count over 1. So if you count over 1, it counted up 2, and it was right on that dot there. So that was the a value of 2. It's not always going to be clear. More often than not, it won't be that clear. Okay, another one. We clearly know the vertex, so let's use it because both x-intercepts are decimals. So we have a vertex of 0, 7, and we have a point. Okay, any point that's clear. Let's go right here at 2, 5. Good. And we have an h, a k, an x, and a y. And our equation. So again, you don't have to write down the generic equation every time, but I'm going to just for the note's sake. Oops, sorry, not -5 minus plus k. Okay, so we plug them in. The y is 5, x is 2, minus 0 squared plus 7. Okay, 2 squared is 4, so it's going to give us 5 equals 4 times a is 4a plus 7. We want to subtract the 7 from both sides. So we get negative 2 equals 4a. Divide by the coefficient. And a is negative 1 over 2. Therefore, the equation is y equals negative 1 over 2. Your h value is 0, so you don't even need the bracket there. There is no horizontal shift, so it's just x squared and then plus 7. Okay, this time we do have a vertex, but let's use our factors. Okay, we have an x-intercept of negative 1, another x-intercept of positive 3. And we know the equation is y equals a bracket x minus r x minus s. So we have r equals negative 1, s equals positive 3, and then we need a point. Well, let's just choose that vertex as the point this time, and that is at 112. Okay. All right, so we have 1 plus 1, because remember the r equals negative 1, it's the opposite in the brackets, and 1 minus 3. So we get 12 equals a times 2 times negative 2. So 12 equals negative 4a. And we're going to divide both sides by negative 4. So a equals negative 3. Therefore, the equation is y equals negative 3x plus 1 x minus 3. Okay, over here, 2 x-intercepts, r is 0, s is 7, and let's use the point. We don't, well, the vertex goes through a decimal, so let's use this point at 6, negative 3. Okay, so negative 3 equals a. 6 minus 0 and 6 minus 7. So negative 3 equals negative 6a. Divide both sides by negative 6. And a is 1/2. So therefore the equation is y equals 1 over 2. Again, don't need an x minus 0, so x minus 7. Write the equation of a quadratic relation in the form that seems to make the most sense. A parabola with a vertex of 4, 0 and a y-intercept of 0, negative 16. So this one is giving us the vertex. We have an h, k, we have x, y. So we're doing the same thing. Vertex form, our y is negative 16. X is 0, h is 4, and there is no k value. 0 minus 4 is negative 4. Negative 4 squared is 16. Divide both sides by 16, and a equals negative 1. Therefore, the equation is y equals negative 1 x minus 4 squared. Okay, a parabola with x-intercepts of negative 2 and 6 passing through the point 4, 6. So we know r, s, x, y. We get 6 equals a bracket 4 plus 2, 4 minus 6. 6 equals a times 6 times negative 2. So 6 equals negative 12a. Divide both sides by the coefficient. And negative 1 over 2 is a. So the equation is y equals negative 1 over 2, x plus 2, x minus 6. And last one, a parabola with a stretch factor of 2. Okay, so that's the a value is 2, it's stretched. It's reflected about the x-axis, so it's going to have a negative. The equation of the axis of symmetry is 3. That's the h, and goes through the point 2, 5. Okay, so let's set up our equation as is. So it's y equals negative 2. Axis of symmetry is 3, so x minus 3, and we don't know k. I'm going to fill in the x and y now. 5 equals negative 2. 2 minus 3 squared plus k. 2 minus 3 is negative 1. Negative 1 squared is 1. So we get 5 equals negative 2 plus k. And we're going to add the 2 to isolate the k. So k is 7. And the equation is y equals negative 2 x minus 3 squared plus 7.